Okay, so now we move to section 6.2, finding the cumulative distribution function for a discrete random variable. Okay, so if a particular value of capital X is simple X, the probability that capital X is less than or equal to simple X is written as capital F of X. Can you see this? F of X. So this capital Fx is what we denote as cumulative frequency. So actually you might have, the cumulative probability function or the cumulative distribution function. So when we say the word cumulative, if you recall in the previous chapters, we did we worked with cumulative frequency, isn't it? Where we took the sum of all the frequencies. So likewise in cumulative distribution function, we take the sum of the probability. Okay, and we build up the cumulative distribution function denoted by capital F of X. Okay, so capital Fx is found by adding together all the probabilities for those outcomes that are less than or equal to X. Okay, this is written as, so this is really important. Capital Fx equals probability X is less than or equal to X. So this is extremely important. All you have to do is, if you want to find the cumulative distribution function to a certain point, the cumulative probability, what you have to do, you have to add the probabilities of all the X values behind until that point, until that particular point, all the X values that are behind that point to that point, particular point should be added. Okay, so I think the best way to do this is through an example. Okay, and then they say like a probability distribution, a cumulative distribution function can be written as a table. Okay, so let's see an example and let's see how to build the cumulative distribution function. Okay, so we'll do an example. So let's see how to actually build this cumulative distribution function. Okay, so a discrete random variable capital X has a probability distribution given in the table. Can you see the probability distribution? There are for different values of X, there are different probabilities. Draw a table showing the cumulative distribution function capital Fx. Okay, so how do you go for the capital Fx function? So what do you need to do here? Let's draw the table again. And then you write capital Fx. Okay. So how do we fill these values now? So when x is 1, so for each of these x values, you have to fill the cumulative probability. Okay, so basically, as I told you previously, cumulative means you have to add up the probabilities. So they say very clearly to add the probabilities that are less than or equal to x. So when x is equal to 1, what are the probabilities less than or equal to x equal 1? I think you only have x equal 1, right? There's nothing behind that. So which means the probability is 0.1. Are you with me? Okay, how do you get the cumulative probability for x equal 2? So x equal 2 means you go, now remember you have to go to the probability table, okay? So in the probability table, you will add the probabilities for x equals 2 and x equals 1. Okay, so we add both of them. We add both of them, 0.1 plus 0.1, that gives me 0.2. That's how this works. Can you see? And then when x equals 3, what's the cumulative probability? So when x equals 3, you go to the probability table and you add the probabilities for all x values less than or equal to 3. Can you understand? So what are the probabilities for x less than or equal to 3? 0.1 plus 0.1 plus 0.15, which is 0.35. So if I just try to highlight to you, this is actually what? The probability x is less than or equal 3. Can you see? This is the probability that x is less than or equal to 2. Do you guys see this? Okay. Can you quickly, give me the answers for x is 4. So cumulative probability when x is 4, add all the probabilities. 0 0.1, 0 0.1, 0 0.1, 0 0.15, and 0 0.25, which is 0 0.6. When x is 5, you have to add 0.1, 0.1, 0.15, 0.25, and 0.3, which is 0 0.9. And the last one, you have to add everything, right? And obviously, as expected, it should be 1. So this is actually something that is really important, this person. Why? So you know that in this cumulative distribution function, at every place you write the probabilities for that x value and less than that x value. So when you come to the final x value, you need to realize that you're going to add the whole table, isn't it? Which means in the cumulative distribution table, the last x value, the cumulative distribution table, the last x value will always have what? A cumulative probability of 1. This is always going to be 1 in every single cumulative table. In every single cumulative table, the last column, the last cell, the last probability, cumulative probability value will always be 1, because this is the probability x is less than or equal 6, and that in this table includes all the probabilities. So in every table, this the last value in here will always add up to 1. Okay, and then are you going to add the probabilities in the cumulative table? Are we going to add the probabilities in the cumulative table? No, the cumulative table probabilities, it does not make sense to add them. Okay, we only add the probabilities in the probability table. Okay, we do not go to add probabilities in the cumulative table. In the cumulative table, you have the probability, as any probability you get here is, now, for example, if I talk about this probability value, it means it's the probability that x is less than or equal 3. So I don't have any individual probabilities here. Do you understand? In these kinds of tables, we do not have individual probabilities, but we have a range of probabilities. And this is really important, especially the last part I told you is extremely important, that the last cell always will be, it must be 1, and you will be tested on this in the exam as well. So you need to be very clear on this, that this is always 1. Okay, so then let's answer part B. Write down capital F of 5. So how do you say capital F5? So capital F5 is, how much is the answer? 0.9. As you can see, F5 is 0.9. And then the next one, capital F of 2.2. Now 2.2 means what? Now remember, capital F 2.2 means probability x is what? Less than or equal 2.2. Isn't it? That's what capital Fx means, isn't it? Probability x is less than or equal to that value. So do we have a 2.2? No, x less than or equal to 2.2 can be written again as what? We can rewrite it again as probability x is less than or equal to 2.2. Instead of 2.2, you don't have a 2.2 here. So what are the x values that are included here? You get the x value 1 included, right? Because x less than or equal to 2.2 includes x value 1. Does it include x value 2? Yes. Does it include x value 3? No. Can you see? So x less than or equal to 2.2, in other words, is probability x is less than or equal to 2. Because you don't have a 2.2. This is a discrete distribution. You only have those specific values. Do you understand? So x less than or equal to 2, in other words, is what? This is capital F of 2. So capital F2, what's the answer? F of 2, the answer is 0.2. Okay, so next I'll move on to question number 3. The random variable capital X has a probability function. The probability, so it's kx for x values 1, 3, and 5, and k times x minus 1 for x values 2, 4, 6, where k is a constant. Find the value of k. So let's do that quickly. I will draw a quick table for x values 1, 2, 3, 4, 5, and 6. And probability capital X. So the probability values, of course, I told you it depends on the X value, right? So here you can see the probability in this situation because it's Kx and Kx times X minus 1. The probability depends on X. So therefore you get here, when X is 1, it's K into 1. That's K. When X is 2, you have to go with the second line. So when X is 2, it's K times 2 minus 1. 2 minus 1 is 1. So it's again 1K. When X is 3, it's K into 3. That's 3K. When X is 4, it's K times 4 minus 1. That's again 3K. When X is 5, so K into 5, that's 5K. When K is 6, when X is 6, so K into 6 minus 1, that's again 5K. Can you see a simple table? And then how do you get the K value? Total probability will add up to 1. So how much is it? How much is it? So 5K, 5K, 10, 13, 16, 17, 18K. 18K equals 1. Therefore, K equals 1 over 18. K is 1 over 18. And then part B, draw the table given the probability distribution of X. So the table with the probability distribution, X value 1, 2, 3, 4, 5, and 6. And K value is now found as 1 over 18. Input the K value and draw the table. So when for X equals 1, probability was K, right? K is 1 over 18. So X equals 2, it's K. So it's 1 over 18. This one, when X equals 3, it's 3K. 3 times 1 over 18. How much is 3 times 1 over 18? 3 times 1 over 18 simplifies to give you 1 over 6. Is that correct? And again 3K, 3 times 1 over 18 is again 1 over 6. Next one, when X is 5, it's 5K. 5 into 1 over 18 is 5 over 18. And for 6 also, it's 5K. So 5 into 1 over 18 is 5 over 18. So this is the probability distribution. Okay, so this is the probability distribution. Okay, so this is the table. Part C, find the probability X is greater than or equal to less than 5. So what probabilities do we require here? Greater than or equal to means you need X equals 2, you need X equals 3, you need X equals 4. Do we take X equals 5? You can see X is less than 5. Therefore, we do not go for 5. So X equals 2, it's 1 over 18. X equals 3, 1 over 6. X equals 4, it's 1 over 6. How much is the answer? How much? 7 over 18. Is there, yeah, 1 over 18. 7 over 18. Okay. And then part D. They're asking you to find capital F4. How do you find capital F of 4? Cumulative frequency, cumulative distribution, or the cumulative probability 4. How do you do it? Capital F4 is, in other words, probability X is less than or equal to 4. This is what it means, right? So X is less than or equal to 4 means you take the probability of all the X values below 4. Below 4 or below. So what are they? X equals 1 probability is 1 over 18. Are you with me? X equal 2 probability is 1 over 18. X equal 3 probability is 1 over 6. X equal 4 probability is 1 over 6. You add these 4 probabilities. Can I know the answer? 8 over 18, which simplifies 4 over 9. The answer here is 4 over 9. Agreed? And then the last part, part E, f of 1.6. How do you get f of 1.6? In other words, it's the probability X is less than or equal 1.6. You know, you have a discrete distribution table here. Do we have X values? There's no for 1.6 here. So you have X value 1, which we can take here on up. x equal 1, we can take, what can I take the probability x is equal to 2? No, it should be less than 1.6. So in other words, this is directly what? The probability that x is equal to 1. That's the only probability that satisfies here. None of the others do. So the answer will be 1 over 18. Okay, so that's the answer for part E. Okay, so next I'll move to question number 6. They say the discrete random variable capital X has a cumulative distribution function capital Fx defined by, can you see? So this is a capital Fx function, and a capital Fx is also defining probabilities, or basically sum of probabilities, right? So it's 0 for x is 0, and you can see the sum of probabilities is given by this particular expression for x values 1, 2, and 3, and it is 1 for x values greater than 5. You know, probabilities don't exceed 1, right? Which means you mainly have to consider which x values, only 1, 2, and 3, because you know now cumulative probabilities add up. I mean, you only have the probability until 1. So after this point 1, we don't have any more probability. So you need to only consider x value 1, 2, and 3 to build this. So first, let's make the table. So this is x and what? Capital Fx, right? You are making the table of x with capital Fx. So first x value is 1, second x value is 2, third x value is 3. And the capital Fx, you can fill it. The first x value when x is 1, replace x with 1. What do you get here? 1 plus k square over 16. When x is 2, we get 2 plus k square over 16. When x is 3, we get 3 plus k square over 16. So this is the cumulative distribution table. Am I correct? Okay. So now the task is to find the value of k. So how do you get the k value? The task is to get the k value. So from this table, how do you figure out the k value? So I think one of the mistakes, common mistakes that many students do here would be that they actually take all these values, they add it and make it equal to 1. Why? Because you are the usual way that you do with the probability distribution. Is this a normal probability distribution, or is this a cumulative probability distribution? So I did tell you in the previous part, it's a cumulative table. If in the capital Fx table, is it practical to add everything, and are you going to add all these cumulative probability values? No, you only add the probabilities in the probability table, not the cumulative probability. So these probability values, we do not add them. So in the cumulative table, what do? I told you, if it's a capital Fx table, always the last x value. The last x value will give the cumulative probability of what? This cell will always be 1, because this signifies the addition of all the probabilities behind this value. So same story here. Here capital F, the 3 is the last x value we have, right? Which means at 3, we must reach the total probability 1, which means this person should be 1, because you're adding all the probabilities behind 3. Can you understand? You will not add all the individual probabilities and make it equal to 1. So you will write here 3 plus k whole thing square over 16 is equal to 1. So 3 plus k square equals 16 into 1, that's 16. 3 plus k equals root 16. Okay. So we will go for the positive k value. Okay. So plus 4, k equals 4 minus 3, that's k equal 1. So I went for the root. In the root, I took the positive figure. Okay. So we will go with the positive value here. So k is 1. In the exam, these things will be clearly mentioned about this k value. So over here, I went with k equal 1. Can you see? So now after the k value 1, all you have to do is substitute the k value into this equation and get the probability distribution. Okay, so now since the k value is found, okay, let's actually go to find the, in part B, they ask us to find the probability distribution. Okay, so actually over here, let me fix this. This should be x greater than not 5, 3, right? Okay, so as you can see here, okay, so the main x values are 1, 2, 3. And for x value, for any x values before that, the cumulative probability is 0. And for any x value after 3, the cumulative probability is 1. Okay, so I will show you why that is. In a moment, I'll explain. So in an event, you might be confused with what this is. But let's build the probability table for now. Okay, so first, shall we input the k value? So when you input the k value as 1, so x, can I know the cumulative probability values? When k equals 1, 1 plus 1 whole thing square divided by 16. How much is that? 1 plus 1 whole thing square over 16. That's 4 over 16. That 2 square, that's 4. 4 over 16 is 1 over 4. So this answer is 1 over 4. All right, and then 2 plus k square. So 2 plus k is 1 square over 16. 2 plus 1, that's 3. 3 square, 9 over 16. Doesn't simplify, right? 2 plus 1, sorry, k plus 2 plus k square. K is 1, right? Okay, so 9 over 16. Okay. So now I have the cumulative probability values. Time to construct the probability distribution because the question says to build the probability distribution. Okay, so how do we go for the probability distribution? Okay, so the first one, when x equals 1, the cumulative probability is given. But for the first x value, since there are no x values behind this, the cumulative probability and the real probability, they are both the same. Do you agree? In the second one, how do you get the cumulative value of F2? You get F2 by adding the two probabilities over in the probability table, isn't it? So this 1 over 4 plus the individual probability of 2, you add them together to get 9 over 60. Okay? Let's get it. Okay, so I did not go to include the probability, cumulative probability 0 here because it's 0. Okay, so won't make a difference. In an event, you might be wondering why didn't I start with 0 here? Okay, so we go with the one main value. Okay. And then when x is 2, so as I told you, it's 1 over 4 plus this probability here that will equal to 9 over 16. Do you agree? These two probabilities individually add up to 9 over 16. So how do you get the probability of 2? Individual probability 9 over 16 minus 1 over 4. Subtract 9 over 16 minus 1 over 4, 5 over 16. And then how do you get the individual probability of 3? So to get the individual probability of 3, we know that you add 1 over 4 plus 5 over 16 plus the probability of 3 to give you what? 1. So what do you do then? So from this 1, you need to subtract the 9 over 16. Basically, you need to subtract the two cumulative frequencies. How much is it? 1 minus 9 over 16 is 7 over 16. So this is the probability distribution. So as you can see, the total probability adds up to 1. Just to clear up one small thing. So over here, what happens if you have the x value 4? Now, just to say, because they have given x values greater than 3, I want to explain how this becomes 1. Now, the total probability is completely consumed here, right? Until at this point, the total probability is 1. So if you are including the x value 4, what will be the probability of x value 4? It will be 0. So what if you try to add the column for the cumulative column for 4? You will be adding all these probabilities, right? So when you add these three, it's 1 plus this 0. This is again going to be 1. Can you understand? So that's why they say when x value is greater than 3 means it's 4, 5, 6. So for those values, it will, because these individual probabilities are not going to have any value. They're 0. Which means if you try to make this table long, it will all be 1. That's why you have this. Is this clear? Okay. Okay, so this is the final answer and this is the probability distribution for x. Okay.